Hello, we're going to do fractions for starters today to recap what we were doing last week. So first of all, we've got two mixed numbers that we're adding together. So we need to make sure we've got a common denominator for the fractions. So we're going to leave the whole numbers as they are, and then we're going to look at the 3/4 and the 1/3, and we're going to make them into fractions with a common denominator. So looking at the 4 and the 3, the smallest number that 4 and 3 both go into is 12. So that's what we're going to put in the denominators. And then we need to make sure that whatever we've done to the bottom, we do to the top. So to change this 4 into 12, we've multiplied by 3. So we need to do the same here. So that gives us 9. Then to change this 3 into 12, we've multiplied by 4. So we need to do the same here. So altogether, we've got 11 add 2 is 13. 9 twelfths and 4 twelfths makes 13 twelfths altogether. But remember, you can't have a mixed number with an improper fraction in it. So 13 twelfths, remember, is 1 whole one and 1 twelfth. So altogether, we've got 14 whole ones and 1 twelfth. Okay, and then the next one, we've got a divide. And remember, when you're multiplying or dividing mixed numbers, you've got to change them to improper fractions. So here, we're going to change our 5 1/2. So remember, we do this times this, add this. So 2 times 5 add 1 is 11. And 2 times 4 add 3 is also 11. So we've got 11 halves divided by 11 quarters. Remember, to divide by a fraction, you turn it upside down and multiply it. Okay, and now recall that you can, when you're multiplying, you can cancel anything on the top with anything on the bottom. And look, we've got 11 on the top and 11 on the bottom. And then we've got a 4 on the top and the 2 on the bottom. They're both in the 2 times table, so dividing them both by 2. There's 2 2's there, there's 1 2 there. So altogether, on the top we've got 1 times 2 is 2. And on the bottom we've got 1 times 1 is 1. And then 2 over 1, remember, means 2 divided by 1. So that's just 2. Okay, so here's what we've been doing and what we've been up to. So yesterday we looked at increasing and decreasing amounts by a percentage, and sometimes that's called appreciation and depreciation if it's to do with prices. So today what we're going to look at is compound percentages. And compound percentages are where an amount is, I should say is there, look at that, just a minute. Hold on. Is increased or decreased by a percentage more than once. Okay, so what we mean by that is, for example, in a bank account, you get an amount of interest per year. Remember, they call that per annum. And if you leave money in an account for more than a year, then you're getting the percentage on top of the percentage, if you leave it. Okay, so appreciation, depreciation, this can happen if it's over a few years as well. Rates of infection are particularly topical at the moment, because if the amount of people in a population who have a virus, for example, if that increases by, say, 3% per week, then you've got 3%. And then you've got 3% on top of your new amount, and then 3% on top of your new amount. Okay, so also reproduction of bacteria over time and number of animals in a population. If they, for example, if you're looking at an endangered species and the amount of that animal or the number existing of that animal is decreasing by, say, 15% a year, then in the first year, it'll decrease by 15%, but in the second year, it'll decrease by 15% of the reduced number. So it's 15% off every time. Okay, we'll see what we're doing here. What we're going to do is, this example, we're going to do it 3 different ways. Okay, and I hope you'll see that the last way is the best way. Okay, so house prices are said to rise at a rate of 2% per annum. A house was bought 3 years ago for £165,000. Calculate its current value. Okay, so the long way would be to work out... Oh dear, not that colour. No good. The long way would be to work out 2% of 165,000 and then add that on to 165,000. So to work out 2%, remember that means 2 out of 100, or 2 divided by 100 times 165,000. And when we work that out, so this is going to be a calculator lesson today, we get 3,300. So at the end of 1 year, it would have been, the price would have increased by £3,300. So it would be the 165,000, add the 3,300, and that gives you 168,300. Okay, so that's after 1 year. So then after the second year, so it's going to increase by 2% again. So it's not 2% of 165,000 though, because this house is now worth 168,300. So we're going to work out 2% of 168,300 gives us 3,366. So we're going to add that on. So after 2 years, it's what we had at the end of the first year. Add the increase. Is 171,666. And then we need to work out for the third year 2% of that. Is £3,433.32. I didn't bother writing out the working, and I think you know how to do that, don't you? So after 3 years, you'd have what you've got at the end of 2 years, add what we've got at the end of the third year, and that gives us 171,666. Add 3433.32 is 175,099.32. Okay, so £175,099.32. Although realistically, if you're talking about house prices, you're not bothering about the pence. Okay, so that's the reason why it's called compound interest is we're not just working out 2% of this and then timesing it by 3 and adding it on. Okay, that's not how things work when it's compound. So you increase by 2% and then you increase that by 2% and then you increase that by 2%. Okay, so that's why it's compound, because you're adding your interest on top of interest that you've already gained. Okay, now I hope you can see that using what we learnt yesterday, there is a quicker way of doing this. So if we start off with our 165,000, okay, and we want to increase it by 2%, remember the shortcut where we looked at starting off with 100% and adding our percentage, so that'll give us 102%, and then writing that as a decimal, and that becomes the multiplier. Okay, so after year 1, we would have 165,000 times 1.02. If we wanted to increase that by 2% again, we would just multiply it by 1.02 again. And then if we wanted it after 3 years, we can just multiply it by 1.02. So every time we multiply by 1.02, we're increasing it by 2%. Okay, so we can see that here, if we work out 165,000 times 1.02, if we press equals at that stage, we get this number here, the 168,300. Okay, if we multiply it by 1.02 again and press equals, we get the value at the end of the second year. And if we multiply by 1.02 again, we end up with the £175,099.32 that it took us quite a lot of calculating to get to here. Okay, so by using a multiplier, we cut out the calculating the percentage and adding it on that we were doing earlier. So there is an even shorter cut than that, and that is, if you take your original value and you multiply it by the multiplier, that tells you what you've got at the end of 1 year or 1 week or whatever your time period was. Okay? But if you're doing compound percentages, you're multiplying by this multiplier over and over sometimes. So what we have is a power on the multiplier. So can you see that what we wrote here, this 165,000 times 1.02 times 1.02 times 1.02, we could write that more simply as 165,000 times 1.02 to the power 3. Because multiplying by something 3 times means you're multiplying by it to the power 3. Okay, so this is how our formulas, I suppose, are going to look. You will have the original value, you'll have the multiplier, and you'll have a power, and the power is how many years or how many weeks or how many times this percentage change has happened. Okay, so if we just simply work this out on the calculator, 165,000, too many zeros that I just pressed there, times 1.02 to the power 3, you get straight to 175,099.32. Okay, and none of this stuff needs to be included. It's only this bit here that you need. Okay, so just a note, when you're using a calculator to do the power 3, if you've got a Casio calculator, it might say X to the Y or Y to the X. That's the button that you're going to need to use. If you've got an Aurora calculator, it might be that you need to press that little hat button with a 3 after it. Okay, so to get a power, you also might have X with a square there as well. Okay, so if you're not sure how to find the power button on your calculator, just send me a picture of it, either on Teams or by email, and I'll show you where it is if you're not sure. Okay, so that indeed is the best method of all. So now we're going to look at a few examples. Okay, so remember what we're starting off with. It's our original value times the multiplier, and then the multiplier will be to a power, and the power is the number of times you're changing by the percentage. Okay, so here what we've got is Elizabeth invests £4,000 in an account paying 2.5% compound interest per year. How much will she have in the account after 5 years? So you won't usually see this word compound interest, the word compound in there. You've just got to know that it's compound. Okay, I've just put that in there to highlight the fact that we're not just working 2.5% and timesing it by 5 and adding it on. That's not what we're doing. Okay, so we're going to need our multiplier. So if you're getting interest, that means you're increasing. So our 100% that we're starting with is being increased by 2.5% to give us 102.5%. And remember, to get the multiplier, you divide that by 100. So I'm going to say M equals 1.025. Okay, you can either do that in your head or on a calculator, doesn't matter. But all you're doing is moving your digits here 2 places to the right when you're dividing by 100. Okay, so our formula for this one is going to be our original value, so that's £4,000, times the multiplier, so that's 1.025, and the number of times this percentage change is happening is 5, so our power is going to be 5. So that's all you need to work out on the calculator. 4,000 times 1.025 to the power 5, and that gives you 4525.6328 and other numbers. So remember, this is money. So the amount that she'll have in the account after 5 years is £4,525.63. Okay. So this is our answer here. Okay. Right, we'll do the next example. The value of a car depreciates by 20% per annum. So remember, per annum means per year. If the car cost £15,000 new, how much will it be worth when it's 4 years old? Okay, so we're depreciating, which means we're going down by 20% per year. Okay, so remember, we're starting off with 100%, we're going down by 20%, so that leaves us 80%. So our multiplier, remember, we divide this by 100, so that'll give us 0.8. Okay, so to work out the car's value after 4 years is our original value of £15,000 times our multiplier, which is 0.8, and the power is 4 because this percentage reduction has happened each year for 4 years. Okay, so when we work that out, 15,000 times 0.8 to the power 4, we get 6144, and remember, this is money, so we need our pound sign. So after 4 years, a car that had been worth £15,000, if it reduces by 20% a year, will only be worth £6,144. Okay, and then, next question. If you get a pay rise of 2% each year from a starting salary of £21,500, what will your salary be after 5 years? Okay, so again, we need to find our multiplier to start with. So we start off with 100% and we're getting a pay rise of 2%. So we've got 102% there. So our multiplier is our percentage divided by 100. So it's 1.02. Okay, so then our little formula is we start off with our original value and we multiply that by the multiplier to the power 5, because this 2% increase is happening year on year for 5 years. So when we work that out, we get 23,737.737 and other numbers. So in money, £23,737.74. Okay. And then the last one, you rent a flat for £500 per month. The rent increases by 3% each year. How much rent will you be paying after 3 years? So we start off with 100%. It's going to increase by 3%, so that'll leave us with 103%. So our multiplier is 1.03 because we divide that percentage by 100. So our amount of rent that we'll be paying after 3 years is our original amount times the multiplier, 3 years. So 500 times 1.03 to the power 3 gives us 546.3635. So again, remember it's money, £546.36. Okay, so our process there is, first of all, work out what percentage you end up with, change that into a decimal, and then all you're doing is taking your original value, times it by the multiplier, make sure you know what the power is, and then just work it out on the calculator and round it where you need to. Okay, so that's us for today. We're going to do some more practice of this tomorrow, but there's a few practice questions for you to have a go at as well. See you then.